Hey everyone, and welcome to our first video on logic. In this video, we are going to introduce propositional logic, or if you want to impress your friends at parties, you can use the fancier phrase propositional calculus. So let's start. Why do we, as computer scientists, care about logic? Well, there are three main reasons, three places that logic comes up in computer science. So, first, logic is used in the design of low level computer operations. Remember that computers are fundamentally made of circuits, and if you want to design a circuit that performs a specific kind of operation, we use logic, in fact, a very similar kind of logic to what we're about to learn, in order to design that circuit, in order to create a circuit that has the desired outcome. And this is an aspect that you'll study a lot more in a course in computer architecture. Second, logic is used when creating computer programs. So if you have experience writing computer programs or especially debugging computer programs, you have used logic many, many times in order to solve your problem and figure out what's going on. And you might have practiced this in a course in Intro CS, but really all CS classes. You're going to practice using logic to design computer programs. And then, third and finally, and this is really the way that propositional logic is going to especially come up for us in this course, discrete mathematics, logic is used to write mathematical proofs. Mathematical proofs. So, why do we care about mathematical proofs? Especially as applied computer scientists, we care about mathematical proofs because mathematical proofwriting techniques can be used to prove the correctness of computer programs. You have a cool Python function that performs a task. How do you know that that function does the task correctly? How do you know with certainty that it works? Mathematical proofs and logic, which is the backbone of those proofs, can be used to perform this task. So, this is why we care about propositional logic. And this last form here, this last idea, using logic for proofs of computer programs. So we're going to think about this a lot in this class. And you're going to see this a lot more in advanced courses on computer science theory. Okay, so that's our quick overview of why we care about logic. Let's go ahead and jump. Propositional logic is made out of fundamental building blocks called logical statements or propositions. A logical statement or a proposition, these words mean the same thing, is simply a statement which is unambiguously true, and which we will often abbreviate with T, or false, which we will often abbreviate with F. So here are some examples of logical statements, also called propositions. So here's one example. I wore a red shirt on September 2nd, 2024. Here's another one. All humans are mammals. Here's another one. 2 plus 2 equals 4. And here's one last one. 2 plus 2 equals 3. So these are all statements that are unambiguously true or false. So today is September 2nd, the day I'm recording, and I am not wearing a red shirt. This statement is false. All humans are mammals. This statement is true. That's a fact about biology. 2 plus 2 equals 4. That's a mathematical fact. That's also true. And 2 plus 2 equals 3 is a falsehood. So remember, logical statements don't have to be true. They just have to be unambiguously true or false. You can think about them a lot like Boolean variables that you would have encountered in a programming language like Python or Java. There's a few things that can kind of look like logical statements that aren't. So I'm going to call these non-examples. So here's something that kind of looks like a logical statement, but it isn't. X equals 3. So the problem with this statement is that, or this non-statement, is that I don't know whether it's true or false because I don't know what the value of x is. I can't say whether this is correct or not because I don't know what the value of x is. Similarly, here's another one. Radishes taste good. Let me just move this over that way. Okay. Radishes taste good. So this is subjective. It's in the eye of the beholder. Whether you like radishes, I happen to like radishes, but you don't have to. So when we are working with logic, we are always working with logical statements or propositions, things that are unambiguously true or false.